Step into the mesmerizing realm of cosmic possibilities, where the delicate dance between a star and its orbiting planets unveils the secrets of life's potential. Join us on a mind-bending voyage as we explore the captivating concept of the circumstellar habitable zone, where the stage is set for worlds to flourish and the delicate balance of existence teeters on the edge of cosmic serendipity. In astronomy and astrobiology, the circumstellar habitable zone, CHZ, or simply the habitable zone, is the range of orbits around a star within which a planetary surface can support liquid water given sufficient atmospheric pressure. The bounds of the CHZ are based on Earth's position in the solar system and the amount of radiant energy it receives from the sun. Due to the importance of liquid water to Earth's biosphere, the nature of the CHZ and the objects within it may be instrumental in determining the scope and distribution of planets capable of supporting Earth-like extraterrestrial life and intelligence. The Goldilocks zone. The habitable zone is also called the Goldilocks zone, a metaphor, allusion, and antonomasia of the children's fairy tale of Goldilocks and the Three Bears, in which a little girl chooses from sets of 3 items, ignoring the ones that are too extreme, large or small, hot or cold, etc., and settling on the one in the middle, which is just right. Since the concept was first presented in 1953, many stars have been confirmed to possess a CHZ planet, including some systems that consist of multiple CHZ planets. Most such planets, being either super-Earths or gas giants, are more massive than Earth because massive planets are easier to detect. On November 4, 2013, astronomers reported, based on Kepler data, that there could be as many as 40 billion Earth-sized planets orbiting in the habitable zones of sun-like stars and red dwarfs in the Milky Way. About 11 billion of these may be orbiting sun-like stars. Proxima Centauri, located about 4.2 light-years, 1.3 parsecs, from Earth in the constellation of Centaurus, is the nearest known exoplanet and is orbiting in the habitable zone of its star. The CHZ is also of particular interest to the emerging field of habitability of natural satellites because planetary mass moons in the CHZ might outnumber planets. History. The concept of a circumstellar habitable zone was first introduced in 1913 by Edward Maunder in his book, Are the Planets Inhabited? The concept was later discussed in 1953 by Hubertus Strokehold, who in his treatise, The Green and the Red Planet, a physiological study of the possibility of life on Mars, coined the term ecosphere and referred to various zones in which life could emerge. In the same year, Harlow Shapley wrote Liquid Water Belt, which described the same concept in further scientific detail. Both works stressed the importance of liquid water to life. Determination. Whether a body is in the circumstellar habitable zone of its host star is dependent on the radius of the planet's orbit. For natural satellites, the host planet's orbit, the mass of the body itself, and the radiative flux of the host star. Given the large spread in the masses of planets within a circumstellar habitable zone, coupled with the discovery of super-Earth planets which can sustain thicker atmospheres and stronger magnetic fields than Earth, circumstellar habitable zones are now split into 2 separate regions. A conservative habitable zone, in which lower-mass planets like Earth can remain habitable, complemented by a larger, extended habitable zone, in which a planet like Venus, with stronger greenhouse effects, can have the right temperature for liquid water to exist at the surface. Solar System Estimates. Estimates for the habitable zone within the solar system range from 0.38 to 10.0 astronomical units, though arriving at these estimates has been challenging for a variety of reasons. Numerous planetary mass objects orbit within or close to this range and as such receive sufficient sunlight to raise temperatures above the freezing point of water. However, their atmospheric conditions vary substantially. Desert planets. A planet's atmospheric conditions influence its ability to retain heat so that the location of the habitable zone is also specific to each type of planet. Desert planets, also known as dry planets, with very little water, will have less water vapor in the atmosphere than Earth and so have a reduced greenhouse effect, meaning that a desert planet could maintain oases of water closer to its star than Earth is to the sun. The lack of water also means there is less ice to reflect heat into space, so the outer edge of desert planet habitable zones is further out. Habitable super-Earths. The 2007 discovery of Gliese 581c, the first super-Earth in the circumstellar habitable zone, created significant interest in the system by the scientific community, although the planet was later found to have extreme surface conditions that may resemble Venus. Gliese 581, another planet in the same system and thought to be a better candidate for habitability, was also announced in 2007. Its existence was later disconfirmed in 2014, but only for a short time. As of 2015, the planet has no newer disconfirmations. Gliese 581 grams, yet another planet thought to have been discovered in the circumstellar habitable zone of the system, was considered to be more habitable than both Gliese 581c and d. However, its existence was also disconfirmed in 2014, and astronomers are divided about its existence. Near-Earth-sized planets and solar analogues. Recent discoveries have uncovered planets that are thought to be similar in size or mass to Earth. Earth-sized ranges are typically defined by mass. The lower range used in many definitions of the super-Earth class is 1.9 Earth masses. Likewise, sub-Earths range up to the size of Venus, 815 Earth masses. Habitability outside the CHD. Liquid water environments have been found to exist in the absence of atmospheric pressure and at temperatures outside the CHD temperature range. For example, Saturn's moons Titan and Enceladus and Jupiter's moons Europa and Ganymede, all of which are outside the habitable zone, may hold large volumes of liquid water in subsurface oceans. As the curtains fall on our exploration of the circumstellar habitable zone, we are left in awe of the delicate dance between a star and its planets, the intricate balance that holds the potential for life to thrive. The boundaries of this cosmic oasis, where conditions are just right, beckon us to ponder the vastness of the universe and the rarity of our existence. The circumstellar habitable zone serves as a constant reminder that our home planet, nestled within this celestial sweet spot, is a precious gem in the vast expanse of the cosmos. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.